The Earth's crust is always shifting and changing, but its most dramatic moves are happening below the waves where we can't see them. Since 2010, for example, parts of the seafloor off Japan have been rising up at an average rate of about 7 centimeters per year. But what's really cool is that the land has been pushed up in some places by as much as 4 meters since 2010. That's like 13 feet in less than a decade. This mysterious uplift is still going on today. And while scientists have had some clues about what might be causing it, a new study published this week in the journal Nature says that satellite data reveals the true culprit. And turns out it's not just happening in Japan, it's occurring all over the world. Earth's surface isn't a solid shell. Instead, it's made up of lots of irregularly shaped pieces called tectonic plates that move around on top of the planet's hot, gooey mantle. These plates often move only a few centimeters per year, which is why it can take millions of years for continents to drift across the globe. But sometimes these plates can move much faster. They may collide with each other or get stuck on a hot spot of magma, causing them to suddenly pop up from the depths. And when it happens underwater, the result is a cool mountain range on the seafloor known as a seamount. Scientists aren't exactly sure how fast seamounts can rise. The fastest ones could gain more than a meter every year, according to a study published in 2019. But that study relied on data collected from ships equipped with sonar, which can only measure seafloor topography at specific points, not continuously across large areas. So it was impossible to know if those were the fastest seamounts or just some of the fastest ones. In the new paper, researchers used data from the European Space Agency's, ESA, Earth observation satellites. These satellites pass over every point on the planet's surface twice per year, measuring changes in elevation down to the millimeter. By comparing elevation data collected at different times, the researchers identified areas of the ocean floor that had risen up by more than 30 centimeters in the last decade. They found 65 such areas concentrated in 4 regions: the Mariana Islands, Japan, the Eurasian Islands, and New Zealand. But that's not all they found. Using the same data, they also calculated the rate at which these areas were rising. And they discovered that some of the slowest seamounts rise even faster than previously recorded instances of rapid uplift. What's more, the team found that many of the newly uplifted areas were not near tectonic plate boundaries, meaning they weren't created by the usual suspects that cause seafloor spreading like divergent plate boundaries or hotspots. So what's going on here? Well, to find out, the researchers analyzed data collected by a network of ocean bottom seismometers called the Seafloor, a worldwide network, recording the strength and timing of seismic waves generated by earthquakes around the world. This network helped researchers identify which of the newly uplifted areas were actually caused by volcanic activity. The team found that nearly half of the areas that were rising quickly were not volcanically active, which means they probably weren't created by the usual method that builds up seamounts layer upon layer of lava. That suggests there must be another way that seamounts can form. In fact, back in 2019, scientists had already proposed that this is what's happening in Japan. Researchers suggested that instead of being built up from lava, the land there is being pushed up from below by something called a megathrust earthquake. That's when 2 tectonic plates suddenly slip past each other along a fault line. The resulting wave of energy radiates outward, causing the ground to shake. But it can also push up the seafloor in certain circumstances. And now this new study provides evidence that this kind of seafloor pushing is happening all over the place. What's more, the researchers say it likely plays a role in the formation of the majority of seamounts. But this doesn't mean that these megathrust earthquakes are causing all seafloor uplift. Scientists still think that plate tectonics play a big role too. For instance, in the Mariana Islands, researchers know that the seafloor is spreading because they've actually seen new seafloor forming at a mid-ocean ridge nearby. This ridge is where the Pacific plate is moving away from the smaller Philippine sea plate. As a result, new seafloor is created and pushed toward the Mariana Islands. There, it's being lifted up by a series of megathrust earthquakes along the subduction zone, where the Pacific plate is sliding under the Philippine sea plate. On the other hand, In Japan, the Philippine Sea Plate is pushing up against the Eurasian Plate. In this case, the Philippine Sea Plate is neither creating nor destroying seafloor, so the uplift must be driven by megathrust earthquakes alone. In the end, the researchers say that their findings suggest that there are more similarities than differences between seamounts that form at mid-ocean ridges and those that form in the middle of tectonic plates. They also say that understanding how seamounts grow will help scientists keep track of the planet's ever-changing surface. After all, seamounts can affect how ocean currents churn and how sound travels through the water. So knowing how they change over time could improve our ability to predict everything from weather patterns to the success of submarine communication. Plus, the fact that we're still discovering new things about Earth's surface shows that there's always more to learn about our home planet, and you can be part of that discovery. At Brilliant, they offer courses in math, science, and engineering that help you learn by doing. When you take a Brilliant course, you'll build problem-solving skills by working through interactive challenges. You'll get a chance to test your understanding with quizzes, and when you finish a course, you can even earn a certificate to show off your accomplishment. Brilliant has thousands of lessons to choose from, no matter your skill level or interests. For example, their Everyday Math course can help you brush up on your arithmetic, or their Introduction to Linear Algebra course can give you a taste of higher-level math. Or maybe you want to dive into engineering with their Engineering and Design course, which introduces you to concepts like forces and motion. Thanks for watching this CI Show video, and thanks to Brilliant for supporting it.